This lesson is about inverse functions. By the end of this lesson, you should be able to rewrite equations as inverses by switching the x and y and solving for y. You're going to take notes, practice some problems, and complete a homework quiz on 6.3 and 6.4 in order to prove that you understand how to write inverses and perform operations on functions and composition. So essentially, when we find an inverse of a relation, we switch the x and y, right here, switch the x and y, and then solve for y. And the y that we get, or the function that we get at the end, is our inverse. So in this case, we have y equals 3x minus 5. So we're going to switch the x and y, meaning literally take those two letters and change places. And then we have to solve for this y now. So in order to do that, I need to add 5 to both sides. And we get x plus 5 equals 3y. And then to get y by itself, we divide both sides by 3. So our inverse, which we write as y to the negative first power, is equal to, either we can write it as x plus 5 over 3, or make sure you understand that is the same thing as 1/3 x plus 5/3. Those mean exactly the same thing. Most times we're going to see it look like this. A few times we're going to see it look like this, so we need to make sure that we understand that both of them work. And remember that this -1 here is just a notation that means inverse. It doesn't necessarily mean y to the -1 power. So why don't you pause the video and try this one. So this problem right here is actually super fast. We just switch the x and the y and solve for y by subtracting 4. So we get x minus 4 equals y. Done. Sorry, to the -1 to say that it's the inverse. So why don't you pause the video again and try this one yourself. Okay, so we're going to switch x and y. X equals 2y minus 1. And then solve for y. So add 1 to both sides and end up with x plus 1 equals 2y. And then to get y by itself, divide both sides by 2. So the inverse of y is equal to either x plus 1 over 2 or 1/2 x plus 1/2. Like that. So now they're going to ask us to prove that two functions are inverses of each other. And in that case, we're going to compose the two functions together, meaning we're going to take one of the functions and plug it into the other function and simplify it down until we get the result to be x. If the result is not x and they are not inverses of each other, it's probably easiest to plug in the fraction equation into the whole number equation. That way when we distribute, we don't have to worry about the fractions anymore. So let's do that. We take 3 and then plug in that 1/3 x plus 5/3, and at the end subtract 5. So then we distribute, and 3, here I'll do this over here, 3 times 1/3, 3 is the same as 3 over 1, those cancel, so we just get 1x, plus 3 over 1 times 5 over 3, the 3's cancel, and we get 5. And then we still have that minus 5. Then we simplify further. Positive 5 and -5 is 0, so we end up with just x, which is what we want up here. So in that case, these two are definitely inverses of each other. So why don't you pause the video and try this one on your own. So we want the inverse of this function, so we need to switch around the x and the y. And then solve for y, so we add 1. And we want to get y by itself, so we divide everything by 4. So y is equal to 1/4 x plus 1/4. Or y, the inverse of y, is equal to x plus 1 over 4. Either one of those is fine. Now you try this one. When we switch the x and the y, this one's a little bit tricky because we have that fraction, but we'll be able to deal with it later. So we subtract 2 from both sides, and we end up with x minus 2 equals -2/3 y. Now remember, when we have a fraction in front of the variable, in order to get rid of the fraction, we need to divide by that negative 2/3, or dividing by a fraction is the same as multiplying times the reciprocal. Multiplying times the reciprocal. And then we distribute. We distribute this 3/2. So we get the inverse of y is equal to negative 3/2 x. And then negative 3/2 times a negative 2, because remember it's negative 2 here. Negative 2 is the same as 2 over 1. The 2's cancel, so we get negative 3 times negative 1, which is a positive 3. Like that. Go ahead and try this one. This one is a little bit tricky because of those we have 2 fractions now instead of just 1. So we're going to switch around the x and y just like we did before. Let's do that. So we have x equals negative 3/5 y plus 7 over 5. And we're still going to go about the process just like normal. So subtract 7/5. And you end up with x minus 7/5 equals negative 3/5 y. And just like the last problem, we're going to multiply times the reciprocal. 5 over 3. Notice that it's still negative, so it's not changing the sign. We're just flipping it upside down. And then we distribute that 5/3. So the inverse of y is going to be negative 5/3 x. And then I'll show you the work over here. Negative 5/3 times negative 7/5. The 5's are going to cancel. Negative times a negative is a positive, so we end up with positive 7 over 3. So pause the video and try to prove if these two functions are inverses. To prove they're inverses, we take this function and plug it in for the x up there. So we get x minus 4, right? That's where we plugged it in here, and then we had that plus 4 at the end. And negative 4 and positive 4 is 0. So this one is x. So this is definitely inverses. Now you try this one on your own. We take this and plug it in for x. 4 parentheses 1/4 x minus 9/4 plus 9. We distribute. We want to get it all the way down to x. 4 times 1/4. 4's cancel. We just end up with 1x. 4 times negative 9/4. That's the same as 4 over 1. The 4's cancel, and we end up with minus 9. Negative 9 and positive 9 is 0, so we end up with x. So definitely inverses. So here's a workbook page for you to practice some problems on. We are going to have a quiz on Tuesday, December, let's fix that, December 4th, I believe, is the date, on 6.1 through 6.4.